Yes, Fazil, you were telling something. Hello, I'm audible. So you people tried those homework questions?
Yes, sir.
Okay. So all are clear. You can solve all those questions. You have some doubts.
No, I don't know.
You have solved all questions.
Yeah.
The last topic that we were doing was parallelogram law. We were doing parallelogram law of vector addition. Parallelogram law of vector addition. So what were the two conditions to use parallelogram law? There were two conditions to use parallelogram law. What were they? The first one was it deals with two vectors at a time. It deals with two vectors at a time. And the second condition was your vectors should be co-initial. You can use parallelogram law only if your vectors are co-initial. It's valid only for co-initial vectors. This we have discussed in the last class. So you have two vectors A and B, and you're supposed to calculate resultant vector R, which is vector sum of vector A and vector B. It's sum of vector A and vector B. This plus sign here is vector sum. This is vector sum. To do this vector sum, you need three steps. The first step is geometrical construction. First step is construction. Geometrical construction means first you will construct a parallelogram having vector A and B. So say you have, this is your vector A, this one is your vector B. They are inclined at an angle theta. You can take one side parallel to A. You can take another side which is parallel to B, and you can simply complete this parallelogram. The diagonal of this parallelogram, this diagonal R, will geometrically represents A and B. So the geometrical construction says if you can represent vectors by the sides of parallelogram, then the diagonal of parallelogram will represent the resultant vector. So if I write definition of parallelogram law, if two vectors acting at a point are represented in magnitude and direction, by sides of parallelogram taken in drawn from same origin, then their resultant can be represented by diagonal of parallelogram. by diagonal of parallelogram from same origin. So this is the geometrical meaning of parallelogram law. That if you can represent vectors acting at a point by the sides of parallelogram, then its resultant can be represented by the diagonal of parallelogram drawn from the same origin. Just note it down. I will rub it up, and then we will do the next step. So that's step one. The first step is geometrical construction. Okay. So can I erase it? Sure.
Yes, sir, done.
After the first step of geometrical construction, the second step is to calculate magnitude. To calculate magnitude, we will use the geometry of vectors. The important of first step is first step converts your vector problem into a problem of geometry. Your problem was that you have vectors represented by the sides of parallelogram, and the diagonal will represent the resultant vector. Using geometry of parallelogram, we can calculate the value of resultant vector. So for magnitude, we first represent each side of parallelogram by the magnitude of vector. Like side OP represent the magnitude of vector A, side SQ represents the magnitude of vector A, side OS represents the magnitude of vector B, and side PQ would represent the magnitude of vector B, and OQ will represent the magnitude of vector R. So that's the magnitude. So we can extend this vector A. We will drop a normal here. This normal is in. So here, this side OP, which is equal to SQ, this is equal to magnitude of vector A. You can either represent your magnitude like this or this. Both are magnitude. Side OS is equal to PQ, which is equal to magnitude of vector B or just B. That's second. OQ can be represented by the magnitude of vector R, or you can simply write this as R. This is equation number 3. So we represent each vector by the side of parallelogram. Now the next thing is, if I consider this triangle ONQ, this ONQ is a right angle triangle in triangle ONQ. See, your goal, your aim is to calculate OQ in terms of given parameters. Given parameters are the sides of parallelogram and the angle between them. So if I take this triangle ONQ, I can use Pythagoras theorem that OQ square is ON square plus QN square. We can write ON as OP plus PN. So this comes out to be OQ square is OP plus PN square plus QN square. That's equation number 4. We know that OQ is equal to R. We have the value of OP equal to A, but this PN and QN are unknown. To calculate this PN and QN, we will use this right angle triangle PNQ. If this angle is theta, I can say this is theta again. If this is theta, then this is theta again. So in triangle PNQ, I can write sine theta as perpendicular upon hypotenuse, Qn by PQ. Qn. Here PQ is B. So you can write that Qn is B sine theta. That's equation number 5. Similarly, you can write cos theta. Cos theta is again based upon hypotenuse, means Pn over PQ. Pn is unknown, but your PQ is equal to B. So you can again write your Pn as B cos theta. That's equation number 6. You can substitute the value of all in equation number 4. So substitute 1, 2, 3, 5, 6 in 4. I don't have space left. Just substitute these values here and get the value of R. It's simple algebra now. And just let me know when you have written it. I will rub it up. So can I erase it? So I'm erasing it all now. Okay, so if I substitute values here, all values in 4, then you will get, instead of OQ, it's R square. Your OP is A. Your Pn is B cos theta, its whole square. Your Qn is B sine theta whole square. So your R square is, it's A square plus B square cos square theta plus twice of AB cos theta plus B square sine square theta. So you can, in B square cos square theta and B square sine square theta, you can take B square as common. So this is A square plus B square. Once you take B square common, this is cos square theta plus sine square theta plus twice of AB cos theta. Okay, Faiza, it's your first class, huh? Faiza, can we write this cos square theta plus sine square theta? Can we write this cos square theta plus sine square theta as something, Faiza?
Yeah, one.
Yeah, that's one. I didn't notice you, that the new student in class. So r square is a square plus b square plus 2ab cos theta. So you can simply write this as r is its root over a square plus b square plus twice of ab cos theta. So this is how we calculate magnitude while using parallelogram. Now after magnitude, we can as well calculate direction because vectors doesn't have meaning without direction. Vector is incomplete unless you mention direction. So for direction, let's say this resultant is making an angle beta with the vector A. In triangle ONQ. Faiza, would you tell me what's the value of tan beta in triangle ONQ? How much is tan beta in terms of sides of triangle? Faiza. You're not audible, Faiza. How much is tan beta in terms of sides of this triangle? Not audible. You can even just type your answer in chat room if you want. How much is tan beta in this triangle ONQ? Tan beta is, it's perpendicular upon base, right? So perpendicular is Qn, base is On. So you can write your tan beta as it's Qn over OP plus P. That's your tan beta. I call this as equation number 7. I call this one as equation number 8. We can substitute our values. So we have calculated Qn in equation number 6, I guess, right? 6th or 5th?
Fifth.
First, 5th, and 6th in 8th. If I substitute all these equations, then I would get that tan beta is Qn. Qn is b sine theta by OP plus Pn, which is a plus b cos theta. So you can write that your beta is, it's tan inverse, it's b sine theta divided by a plus b cos theta. So this is how we calculate direction. So maybe some of you who are doing this parallelogram law for the first time could be wondering how this beta can tell direction. It's basically in this way. Say this example will clarify this concept. This is east, west, north, south. If I'm saying that a body is moving with some velocity, let's say 10 meters per second, at 30° with x-axis, with east. If I mention this angle, that means you know the direction of velocity. If I'm saying that a force is acting on a body at an angle of 10° with the south, if I mention this angle of 10°, by mentioning this angle of 10°, I'm specifying the direction. Now you can identify in which direction this force F is moving. So just like that, if I know vector A and vector B, these two are given vectors. That means I know the direction of each of these vectors. I know the direction of A as well as B. So just by mentioning this beta, I can easily decide the direction. Just by mentioning this beta, I can decide in which direction your vector is at. Is it clear for everyone? Just by knowing this angle beta, you can decide direction. Is it clear, Rania?
Yes, sir.
Okay. Okay, just note it down. Then we'll do some numericals on this concept. Faiza, have you done parallelogram law somewhere?
Yeah.
You have done. Okay.
Yeah.
Okay. It's just so you are getting it. This derivation of parallelogram law.
Yeah, little.
Little bit. Asani is just a second lecture of vectors. Okay. So at the end of the class, I will share you. Are you in that WhatsApp group? No. Faiza, are you in our WhatsApp group of class?
No.
You're not there. So if you have any of, do you have any friend in this batch? Fatma. Yeah, you have
Fatima.
Fatma. Fatma, can you please share the first lecture of vector with Faiza?
Yes, sir.
So I've already placed that lecture on WhatsApp group. Huh? Please share that first lecture with Faiza.
Okay, sir.
Well, it's just the second lecture. Fine. It's just the second lecture. Let me know when you have written. I will erase it and we'll do some problems on this concept. Okay, Noor says done. Noor have written. Everyone have written this?
Yes, sir.
Yes, sir.
So let me just summarize this thing. Faiza, I'm just summarizing in 2 minutes what we are exactly doing. We're basically trying to add two vector quantities. Vector quantities are quantities which have directions also, like along with magnitude. Quantities which also have directions are vector quantities. That's it. So to calculate two vectors, three steps are involved. The first step is we will make a parallelogram using given vector. In the step 2, using this formula, we will calculate the magnitude of resultant vector. And then using this formula or this formula, we will try to calculate the direction. So whenever we add two vectors where angle is given, we use this method, these three steps. The first example will clarify the concept. Say you have two forces, a force which is acting in this direction, you have another force which is acting here. This is force F1, which is of 1 Newton. You have force F2, which is of 2 Newton. These two forces are acting at an angle of 60 degrees. These two forces are acting at an angle of 60 degrees. I ask you to calculate net force. Calculate net force. So to calculate net force means you are supposed to calculate a force F, which is vector sum of F1 and F2. So Rania, how many steps are involved to add these two vectors? It's a vector sum. Rania, how many steps are involved for this vector sum? Rania is 1. Sorry, I can't hear you. You can as well use chat room, Rania. How many steps are involved in this vector sum?
I don't know, sir.
Sorry,
I don't know.
you don't know. We just have completed vector sum, this parallelogram law. How many steps were involved in using parallelogram law?
3.
3 steps, right? So 3 steps are involved. What was the first step? Rania, what was the first step?
Geometrical construction.
Geometrical construction, right? So you would complete the parallelogram. This diagonal of parallelogram will show resultant vector F. That's the step 1. So this is step 1. You need not derive everything now. You can directly use relation. Then step 2. In step 2, you can calculate your force as the magnitude of force. Faiza, what was the formula for calculating magnitude? The last result that we have derived? Faiza.
A square plus B square plus 2AB cos theta.
So instead of A, I'm using F1. So it's F1 square, F2 square, plus twice of f1 f2 cos 60. Keep on substituting the values. So it's 1 square plus 2 square plus 2 into 1 into 2 cos 60 is half. So gets cancelled out. So you are left with that net force is 4 plus 1, that's root 5. So this is the net force acting on the body at step 2. In step 3, you're supposed to calculate the direction. For direction, we can take angle beta with any of the vector. Let's say I call this as tan beta. For direction, this is the formula. Tan beta is b sine theta over a plus b cos theta.
Sir,
Yes, Sanya.
sir, it will be root 7, right?
Root
7.
6.
Root 7, 4, 5. Yes, it's root 7. Sorry, yeah. Right, it's root 7. It's root 7, definitely. So this is tan beta, b sine theta by a plus b cos theta. So in this formula, there is a small issue. You have to identify that out of f1 and f2, which one is a and which one is your vector b. In this formula, there is no issue of identifying a and b, but in this formula of angle, you have to identify out of f1 and f2, which one is a and which one is b. To identify, we will use a very small logic. The vector with which respect to which you take beta. So the vector with respect to which you take this angle beta is a. Another one is b. I'm repeating it again. So the vector with respect to which you take this angle beta is a, and another one is b. So we have defined this angle beta with respect to f1. So for me, a is f1 and b is f2. So this is f2 sine 60 divided by a, which is f1 plus f2 cos 60. f1 sine 60, f2 sine 60 divided by f1 plus f2 cos 60. So your tan beta is, it's f2. f2 is 2. Sine 60 is root 3 over 2. f1 it's 1. f2 is 2. Cos 60 is half. This 2 will cancel this 2. This 2 will cancel this 2. So you are left with tan beta. It's root 3 divided by 2. Where your beta is, it's tan inverse root 3 by 2. This is beta, which is tan inverse root 3 by 2. This is how we calculate angle. We can write your final result as that the final force is root 7 Newton at tan inverse root 3 by 2 with respect to f1. Is it clear for everyone?
Yes, sir.
Yes, sir.
Listen, there is only one rule in my classroom, and that is you have to understand the 100% of the lecture. If you're not understanding anything, if you have any doubt, please feel free to ask. Each and every numerical that I do is based on the previous one. If you have doubt in this numerical, then it's not possible for you to do the next one. All numericals are in sequence. There is a pattern that I'm following. You have to understand the 100% of lecture. If you're not getting anything, feel free to ask. So, is it clear for everyone? Huh? Faiza, you too? You're getting this numerical?
Yeah.
Okay. Fatma Farhana, just tell me, can you decide A and B if I call this as beta? Fatima, Farhana. If I'm taking this particular angle as beta, can you decide your vector A and vector B? No answer. Fazil, if I say this is my beta, which one? How will you define your A and B? Which one is A and which one is B?
A would be F2, that is 2 Newton.
Yeah, it would be your A, and this would be your B. The choice of A and B depends upon the beta with which we are taking. It's your choice. You can take any of the vector as beta. Yes, Fatima, you're right. You can take any of the vector as beta. Any of the direction as beta means you can take angle of force F with respect to F1 or with respect to F2. That's your choice. But once you have fixed this beta, then the choice of A is not free, not a free choice. It depends upon beta. If you're taking beta with respect to F2, that means your A is F2 and B is F1. If you have defined beta with respect to F1, then right, your F1 is A and F2 is B. So the beta that I have mentioned here is with respect to beta, with respect to this. Just note it down. We'll do one more numerical on the same concept. Just note it down, please.
Sir, done.
Okay. Let's do one more numerical. Again, a formula-based numerical on the same concept. Then we'll do some tricky questions. Next question. Two forces are acting on a body along east and north respectively, as shown in figure. Calculate net force. Calculate net force. So this is the given figure. This is east, this is west, this is north, this is south. This is the force. This is force F1 of 2 Newton, which is acting towards east. This is force F2, 1 Newton, which is acting towards north. You're supposed to calculate the net force. Get the value of net force now. Calculate both magnitude as well as direction of force. Take direction with respect to F1. I'm repeating it again. Take direction with respect to F1. So we just note it down. Answers. I need answer. Whatever you are getting. Don't worry
Sir,
about.
what is the value of theta?
So what is the angle between east and north, Sania?
90 degree. Sir.
You did not worry about the correct answer, whether your answer is correct or wrong. Whatever you are getting, just report your answer in chat. Okay. Direction, Sania. I need direction with respect to F1. What about the rest? Fazil, Noor, Fatma? I need both magnitude as well as direction, because vectors have no meaning without direction. Okay. No, just check your calculations once. You're making mistakes. You're making a very small mistake while calculating magnitude. And what about Fatma, Rania, Faiza? This question is just like the previous one. In the earlier question, angle was 60 degree. Now the angle is 90 degree. That's it. Yes, no. Now it's fine. Okay, Fazil. Fatma, Rania, Sania, I got that. Okay. 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 Anna and Faiza. Faiza, very good. Fatma, Farana, only you are left. Oh, very good. So we just complete this parallelogram. This is your resultant force F, right? This is your force. So force F is vector sum of F1 as well as F. You can write the magnitude of force F as it's F1 square, F2 square, twice of F1, F2 cos 90. Cos 90 is 0. So F is root over F1 square plus F2 square. So you can keep on substituting the values. So F1 is 2 square. F2 is 1, it's 1 square. So force F is root 5e. So everyone is getting the correct answer. Now for as far as angle is concerned, this is beta. So the formula of tan beta is b sine theta over a plus b cos theta. So Faiza, which one is vector A, F1 or F2 in this case? Faiza? Out of F1 and F2, which one is vector A?
F1.
F1, very good. This is A. And this is F2 is B. So this is F2 sine 60 divided by F1 plus F2 cos 60. Not 60. Angle is 90. Sine 90 cos 90. So cos 90 is 0. Your tan beta is just F2 by F1. Or your beta is, it's tan inverse F2 by F1. This is your beta, which is tan inverse F2 by F1. Keep on substituting the values. It's tan inverse F2. F2 is 1. F1 is 2. So this is the value of beta, which is tan inverse 1 by 2. This is beta. So once you have got beta, you can write the direction your force have, that your force F is root 5 Newton at tan inverse half. See? Now, how would you write it tan inverse half? From east towards north, right? If you want to tell the exact direction, if you want to tell this direction to someone, you would say that this force is acting at an angle beta from east towards north. Because from east, it can even move towards south. So just to tell that from east, this angle beta is towards north. Technically, we write it as 5 Newton at tan inverse half north of east. North of east means it's moving towards north with respect to east. With respect to east, moving at an angle beta towards the north. So this is the complete direction. Is it clear up to the last step?
Yes, sir.
Yes, sir.
Very good. Okay, just note it down and tell me when you have written. And when you have written, I want to see response of each and every student. If you have written, just write done in the chat. And if you're too lazy to type done, just type D. That would be enough for me. But at least respond. Very good. So I'm erasing it. So these were two formula-based numericals. Then we have few special cases in parallelogram law. Few special cases. The first case is if vectors are parallel. If vectors are parallel, how would you use this parallelogram law if the given vectors are parallel, if you have parallel vectors? So if you have parallel vectors, like this is vector A and this is vector B. So if you have vectors which are acting in same direction, that simply means that angle between them is 0 degree. Parallel vector means angle is 0 degree. You are supposed to calculate resultant R. Resultant R is vector A plus vector B. So if I calculate magnitudes, it's root over A square plus B square plus twice of AB cos 0. Cos 0 is 1, so we are left with only it's root over A square plus B square plus 2AB. Or you can as well write this as it's A plus B square. So you can write this as R is A plus B. So this is the magnitude of resultant vector R, which is magnitude of A plus magnitude of B. So see, after using the entire parallelogram law, the result that you are getting is just algebraic sum, right? This is not the vector sum. This is the vector sum. But the sum that you are using here is normal algebraic addition. So this is algebraic sum. This simply means if two vectors are acting at 0-degree angle, if two given vectors are parallel, then it's your choice. You can either add them up vectorically using the entire parallelogram law, or you can simply add them up algebraically. You will get the same result. So that's the special case in which this vector sum or vector addition reduced to algebraic sum or algebraic addition. This is the condition if given vectors are parallel. So we can even write this R as mod of R. This is how we represent magnitudes, mod of A plus magnitude of B. We can even write this R as A plus B, vector A plus vector B. It's vector A plus vector B is magnitude of vector A plus magnitude of vector B. Sania, can you tell me, is this vector sum or normal algebraic sum? Sania.
It's vector sum.
Vector sum, very good. And what about this one?
This is also vector sum.
This is not vector sum. See, here you are adding vector A and vector B, two vectors, that's why this is vector sum. But here you are adding just magnitude, right? Mod of A means magnitude, no direction.
Yeah.
That means this is
Algebraic.
see it clearly that vector sum is equal to algebraic sum. This is possible only if your vectors are parallel. This is
Okay.
true only for parallel vectors. This is true only if the given vectors are parallel. Only for parallel vectors. Second, if vectors are anti-parallel. And just one more thing, the direction of resultant vector R. Again, you need not calculate the direction separately. The direction of resultant vector R is same as that of given vector. So that's a very simplified case. Let's do an example on this concept. So you have two forces. This is east. So you have two forces. A force F1 of 2 Newton. This is acting towards east. And another force of 1 Newton, which is again acting towards east. So the net force F is the vector sum of F1 and F2. Now, since they're acting in same direction, you can simply write this as 1 plus 2 equal to 3. You can simply write this as 1 plus 2 equal to 3 Newton. No need to use the entire parallelogram law. Even if you apply entire parallelogram law, you will get the same result. And what about the direction of resultant force? It will act in same direction as that of given vector. So you can simply write this as, this is 2 Newton due east. So here, for direction, you can write R will act in same direction as A and B. So your R will act in same direction as that of vector A and vector B. So this is it. So that's the special case, that if vectors are parallel, then no need to use the entire parallelogram law. Do these calculations directly. Just note it down and let me know when you are done. Okay.
Done, sir.
Okay. So everyone have written. Let's rub it. Rania, have you written it? Rania is one.
So she's disconnected.
Gosh. Choose connected now. So Rania, have you written?
Yes, sir.
Sure. So that was the special case if your vectors are parallel. Then we have another case, case 2. If vectors are anti-parallel. Vectors are anti-parallel. By anti-parallel, I mean a vector A is acting in this direction and D is acting in opposite direction. This is vector A and this is vector B. They're acting in opposite direction, so angle is 180 degrees. But again, supposed to add them up, like you're supposed to add vector A and vector B. So if I add them, then the magnitude of resultant is its root over its A square plus B square plus twice of AB cos 180. Cos 180 is minus 1, so the resultant is root over A square plus B square minus 2. Or you can just write this as A minus B whole square. Square will cancel this root, so R is A minus B. Or you can write this as mod of R is mod of A minus mod of. Or you can write this A plus B as mod of A minus mod of. Rania, can you guess what type of addition is this? Is it a vector addition or algebraic addition?
Vector.
Right. And what about this? Is it a vector addition or an algebraic addition?
Algebraic.
Algebraic addition. So see, vector addition is equal to algebraic subtraction. Vector addition is equal to algebraic subtraction. This is valid only if vectors are anti-parallel. Only if vectors are anti-parallel. For direction, you can simply use this trick that direction of resultant vector R is same as that of vector having greater magnitude. Having greater magnitude. So this is the direction of resultant vector, right? Same as that of vector having greater magnitude. This is how we calculate direction of vector. Next we have case 3. Case 3, if vector, let's do one example on this. So say this is force F1, a force F1 of 2 Newton, and this is force F2. This is of 5 Newton. Faiza, can you identify what type of vectors are there? Are they parallel or anti-parallel vectors? Faiza. Faiza, you're not audible. Are these vectors parallel or anti-parallel?
Anti-parallel.
Anti-parallel. So if I'm adding then these vectors, so what would be the end result? They will get subtracted. So you will subtract F1 from F2 or F2 from F1. Faiza, you will subtract you will write this as F1 minus F2 or F2 minus F1.
F2 minus F1.
Why you're writing F2 minus F1?
because F2 is greater than F1.
Yeah, it's have greater magnitude. So 5 minus 2, which is 3 Newton. This is it. It's 3. So what's the direction? This is east and this is west. 5 Newton is acting towards west. So this is 3 Newton due west. That's the final answer. So is it clear? So whenever we have vectors acting in opposite directions, anti-parallel vectors, so instead of using the entire parallelogram law, we will directly add their magnitudes. Just note it down, then we'll do next topic. Note it down, then we'll do third. Okay. Very good. So let's rub it up. See, next is case 3. So case 3 says if vectors are perpendicular. If vectors are perpendicular, means they're acting at 90 degree with respect to each other. So this is vector A. This one is vector B. Angle between them is 90 degree. So you can write vector R as vector A plus vector B. Since angle is 90 degrees, so it's root over A square, B square plus twice of AB cos 90. Cos 90 is 0, so it's just root over A square plus B square. I will not solve it further. This is the resultant vector, root over A square plus B square. The next is, we can as well calculate the direction. This angle is beta. For tan beta, formula is B sine theta. So instead of theta, you will write 90 by A plus B cos 90. So sine 90 is 1, cos 90 is 0. Your tan beta comes out to be B by A. So instead of using the whole formula, we will simply write B by A if vectors are perpendicular and magnitude as root over A square plus B square. We take an example. So this is your first vector F1, which is 1 Newton. And that's your another vector F2, which is 2 Newton. We completed the parallelogram. This is the diagonal of parallelogram, which represent resultant net forces F. We're supposed to calculate F, which is vector sum of F1 and F2. So we can directly add their magnitudes. In fact, we can write this as it's root over F1 square plus F2 square. It's 1 square plus 2 square. So F is 4 plus 1, that's root 5. This is how we calculate the net force. Next, we'd also need to calculate the direction. Say this angle is beta. Tan beta is B by A. So vector with which you have defined your angle beta is A and this one is your B. So B by A means it's 2 by 1. So your tan beta is 2. Your beta is tan inverse 2. It's tan inverse. This is beta. Is it clear? So this too will save some time. These, if you remember these special cases, then you can save something. So can I erase it? Done. Okay. Stop it. So that was about parallelogram law. Okay, so I have to stop now. See, we have regular 4-hour classes weekly. These are the committed one, the 4-hour week per week classes. But since we have started our syllabus a bit late, so I need few extra hours. So on Friday, I'm taking a 1-hour class. I think it's enough. And for backup, can we take backup on 2:30? 2:30 means 4:30. Can I take a backup class on Saturday at 3:30 p.m.? Saturday, 3:30 p.m., a backup class. I would be discussing calculus in that class, differentiation and integration. So Noor, Sania, and Fazil, they have already done this. Maybe Sania have missed differentiation, but Fatima, Faiza, Rania, you have all joined this batch from 4th chapter. So can you attend this class? Saturday, 3:30 p.m. backup class of calculus. Send your confirmation in chat room if you can join. Yes or no?
Sir, me also.
Yes, Sani, you have missed the class of differentiation.
Yeah.
So I will start with differentiation. You can attend this class. Confirmations, yes or no. If you are not available or there's some issues, you can shift the timings. The class is over now. So Fazil, Noor, if you want, you can leave. I'm just discussing the timings of the backup class.